I was recently on the Coffee, Code, and Chat podcast, link below, and I was asking about my video on the book Clean Code. And since my video dumping on the Clean Code book, there have been three main questions that I've gotten. First question is, if we shouldn't read clean code, and we really want to read something about that topic, what is worth reading? Second related question is, what do you think of this book, The Philosophy of Software Design? And I've been asked about some other software books, but this is the one I'm talking about today. The third question is, isn't the Clean Code book better than nothing? And no, it isn't. It's bad. In fact, it's worse than bad. It's shit. This is the Internet of Bugs. My name is Carl, and today is about this book, The Philosophy of Software Design by John Ousterhout. Short version, this book is much better than Clean Code. It's short, it's concise, and what it says is mostly useful. So if you think the best use of your time is reading something on this topic, it's a pretty good choice. But it has some major limitations, which we'll talk about today. So I'm going to start by going through the book and talk about what's good and what's bad and what's ugly. I'm going to skip Chapter 1 Introduction, takes us to Chapter 2, The Nature of Complexity. It's actually pretty good. I'd like to expand on this section on unknown unknowns though. In my experience, this really undersells the issue. In a previous video, I talked about whack-a-mole, and this unknown unknown situation that he's describing here leads to those whack-a-mole project failures. So I'd argue this is a much worse problem than this book indicates. And unfortunately, the cure for whack-a-mole is one of the many things that this book omits, which is the main problem, which is many problems with this book. It omits so much important stuff. It's kind of naive, actually. Now, what it does have is mostly pretty good. Mostly. So moving on to this section about strategic programming. It's absolutely correct and misses the most valuable part of being strategic. The most important aspect of being strategic about programming is being strategic about your requirements. The main difference between business programming and school assignment programming is you can negotiate with the business, and you absolutely should. Proper software development is a negotiation between the person that wants the software written and the person that is writing it. You know what's possible, and they know what they want. They know what their budget is. You can tell them how much or how long, more or less, what they want will cost and how long it will take, and you can negotiate on, well, if we do it this way instead of that way, it'll take half as long. Those kinds of things. This is the kind of thing that AI can't do. I've talked about this before, but it's a vital, important part of being a competent software developer. And unfortunately, it's the most important part about being strategic, and this book doesn't talk about it at all. So moving on to page 18, Google and VMware grew up around the same time as Facebook, but both of these companies embraced a more strategic approach. This is hilarious, but I don't blame the author, because you never know when you use an example in the book how untrue that's going to be in a few years. Sometimes things just don't age well. Moving on to page 22, here's a line that says, in the definition of abstraction, the word unimportant is crucial. And this is crucial, but unfortunately the author gives you no real way of understanding what's important. There's no a priori criteria I can give you, but you do get an intuition about it over the years. But here are a couple things to look for. First off, pay close attention to bugs as they pop up. If reproducing a bug involves two different sets of conditions to happen in two different places in your code, take a close look at your abstractions. You may well have hidden something that you shouldn't. Similarly, if writing an automated integration test for a particular permutation of a system, and I've talked about integration tests before, if that's difficult because you're having to deal with multiple parts of the code at the same time, then you might have an abstraction problem. Moving on to page 23, the Unix operating system and its descendants, such as Linux, is a beautiful example. And this is absolutely true. He kind of buried the lead here. In a previous video, I recommended Advanced Programming in the Unix Environment and TCP/IP Illustrated as fundamental books for programmers. These two systems, Unix and TCP/IP, conquered the world. There's a reason for that. And one of them is that API designs are so good and the abstractions work so well. They do have issues, don't get me wrong, especially the error handling, which is atrocious, although that's largely about the limitations of the system and the programming language and the performance at the time. We can do better than that now, and we ought to. Also, things like need for real collection types and better memory safety, but those are all things we've learned over the years and gotten better at. But studying and emulating the API patterns for Unix and TCP/IP will take you a long way. Page 26 says the extreme of the classes should be small approach is a syndrome the author calls Classitis. This is a good antidote to the clean code garbage philosophy of like make everything small. Moving to chapter 5, chapters 5 through 9 are fine. They're a big set of contrasts between really crappy Java APIs and much better Unix and TCP IP ones. There are a couple of things I might quibble with, but generally those are pretty good advice. Chapter 10 is a disaster. It contains, but mostly ignores, the single most important line in the book, though. The quote is, "A recent study found that more than 90% of catastrophic failures in distributed data-intensive systems were caused by incorrect error handling." Let me say that again. 90% of catastrophic failures caused by incorrect error handling. This is absolutely true, and this chapter makes it worse, especially since the only mentions of automated testing in this book are tiny, like 2 pages in sections 19.3 and 19.4. We'll come back to this later in the video. Page 83 talks about masking in the NFS network file system. NFX was a disaster. This thing just makes my blood boil. NFS basically is set up so that when there's a timeout error or some kind of error, the system just locks. And it just waits until everything comes back. And if it doesn't come back perfect, then nothing works again. And that means that every single person that wrote code that sat on top of NFS, and it wasn't always obvious when you were sitting on top of NFS, you had to figure out your own how the hell am I going to handle this if something goes wrong thing, because they refused to handle it in a global place. It's an awful example of error handling, and there's a reason why NFS is hardly ever used anymore. So the fact that they use that as an example in this book is just, ugh. Chapter 11, whatever, it's 4 pages on design it twice. There are good things about designing it twice, but there's also a downside. Look up, I'm not going to go into it, but look up Second System Syndrome. It's in Fred Book's seminal Mythical Man Month book, which is another one that I recommend. Designing it twice has advantages and disadvantages. Sometimes it's really awful, so be sure you're aware of the issues with it before you do it. Chapters 12 and 13 are on commenting. I love this. I'm a big fan, as one of my other videos have shown, I'm a big fan of making comments a deliverable and making them important and ignoring when Agile says we don't care about comments, or we deprioritize comments, I guess is what it says. Chapter 14 on naming is okay, but it misses a thing, which is renaming. A thing that happens a lot is you're working on a system and you've got names and the names seem to make sense at the time. And then the system extends itself and suddenly those names don't make sense anymore and it gets confusing. So, concrete example. I was working on a project once where we had a whole bunch of built-in functions, or not built-in, but a whole bunch of functions that we used over and over that were about mapping. And it was all about turning one kind of data into another kind of data. It's like map reduce, that kind of mapping, right? And then that system got an actual map, like Google Maps, Apple Maps, like that kind of thing, right? And so suddenly we're like taking maps and we're mapping maps from one data type to another data type. And it was a complete disaster. It was like, it was confusing as hell. You couldn't keep track of what was going on. And I wanted to change the name of what we were using for mapping because we couldn't really change the name of map because a lot of the map API names were names that were built into the mapping libraries that we were using because we didn't write a mapping library from scratch because that would be stupid. And I got a lot of pushback from the team that didn't want to rename the stuff that they'd already done. And it was just, dealing with that module was just a mess. So when you think about naming things, it's important to remember that the name that you pick right now might be great, but if at some point in the future it becomes bad, you need to be able to rename it, and you need to be able to rename it with confidence, which means you need to have pretty good tests. Chapter 15 is about writing the comments first. I've talked about this before. Yes, please do more of that. Chapter 16 is just a mess of contradictions. Part of it says, keep comments near the code that's relevant to the comments, and part of it says, don't comment at all. Instead, refer to the external documentation. Writing comments on existing code that you didn't write in the first place is always a mess. And I get why there are different strategies and they contradict each other, but it's just, there's no good answer to that, I'm sorry. Chapters 17 and 18 are fine, I guess. They're on consistency and obviousness. They're both really short. Chapter 19 is just useless. It's like 2 pages on object-oriented, 1 page on Agile, 2 pages on automated testing. It's like you might as well not have included that at all, except my guess is that they basically were like, oh, the editor said, you know, we have to have these topics in the book or it won't sell. And so he just added, okay, here's a page on this and a page on this. It does have some good quotes, I guess. Chapter 19 talks about implementation inheritance and some of the problems with it, but it doesn't go into any detail at all, so it's completely useless, but the concept is actually really good. The next page about Agile development talks about how Agile tends to focus developers on features, not abstractions. It doesn't really explain why that's bad. So it's got some good concepts, but it just doesn't take the space or have the time to actually spend any time on them. So chapter 20 is designing for performance, and it's got some pretty good advice on making measurements. Making measurements and benchmarks are really important. On the other hand, there's this quote on page 170. Quote, if you write clean, simple code, your system will probably be fast enough so you don't have to worry much about performance in the first place. This is hot garbage. Clean and simple code is not fast code. It might be fast enough if you're not trying to do anything difficult or in a tight loop or anything. Clean and simple code is always slower than it could be. High performance code is low level, it's fiddly, it's fragile, it's awful, but it's fast. If you want it to go really, really fast, write it in assembler. Now try to maintain it in assembler. It's a nightmare, but it's really fast. Those are your trade-offs, right? The cleaner it is and the simpler it is to understand, the more abstractions it's got and the more stuff it's doing that's taking up time that it doesn't have to if you were doing everything by just copying blocks of memory around. So if you really need high performance stuff, you need to go much lower level. I don't recommend that. Try not to need it. But believing that keeping your code clean and simple will make it go fast is just wrong. Next two chapters are pretty whatever. Chapter 21 is decide what matters and 22 is the conclusion. They're kind of unremarkable. They're very short. So now about what this book doesn't cover. So let's jump back to that 90% of failures quote. There's a very straightforward reason for this. Error handling code only runs when errors happen, and they don't generally happen very often during development. So error handling code is almost always the least executed, least tested code in pretty much any system. And this book is pretty typical of the industry. It spends basically all of its time talking about the fun stuff that programmers like to argue about, and it ignores, or mostly ignores, the most important things. I work with this kid fresh out of a highly regarded CS program at a well-known school. He loved to argue about like what methods should or should not be allowed to be overridden at some far off point in the future by some hypothetical subclass, and was constantly refactoring other people's code to make the method shorter. But the kid could not keep track of what thread he was on to save his life, or he was just utterly unwilling to try. He created tons of concurrency bugs that other people had to clean up because he only wanted to care about software design and thought all of that other crap was beneath him. I had this other guy I worked with on a project. I was working on a team. We had a like decade-old C++ project. It had been through multiple hands. None of us had actually started with it. We had all inherited it. We were like trying to figure it out. We were trying to make it perform well enough to be able to meet these performance targets that we had. And this guy, who was not a kid, he came in, and within a month of being on the project, he reformatted the entire code base to match his preferences for line length, capitalization, method links, white space, all that kind of stuff. Pushed that with only a cursory verification that the part of the code he was working on still worked on his machine, and then he refused to take responsibility for anything that broke in the process. And this is what you get when all you really care about is software design. So don't be like those guys. Programmers want to believe that if they use the right algorithms and design patterns, and the bugs will take care of themselves, and that's garbage. But books like this and clean code reinforce those beliefs because they don't handle the important stuff. They just tell you that 90% of bugs are caused by this thing we're not going to cover. And then when they're confronted with bugs, those programmers like to say crap like, oh, that's so unlikely, it's not worth spending time on, or, oh, I can't reproduce that, so I can't fix it. As far as I'm concerned, how you handle the error cases and the failure modes is way more important than most of the things that programmers usually want to learn about. The things that most software design books and interview questions cover aren't nearly as important as error handling, and nobody cares. And when I talk about the Internet of Bugs, this is what I'm talking about. Most of the bugs, 90% of the catastrophic bugs, according to that paper, happen in the code that deals with the errors, the failures, the retries, the corner cases. This is the problem. And remember, when you think, oh, it's not going to happen, first off, it's the rare and poorly tested corner cases, the error cases that create the worst outcomes for the users. And hopefully we care about the users. If you don't care about the users, get out of the business, because I don't want to use your code and nobody else should be forced to. The second thing is even more important. Understand the internet is not static. Circumstances change. Those changes of the operating system underneath you or the things you're talking to or whatever can cause rare things to start happening way more often. I've seen this over and over again, where this really, really rare corner case, because of some external change to a third-party library or something, started happening all the damn time and caused all kinds of problems. And then the worst case is when a bad actor forces the error condition to take place in your code so they can take advantage of your poor code to hack the system or steal money or do something like that. So saying, oh no, that's not going to happen, it will happen. Maybe not always, but lots of the times. And when it does, it will be bad, and sometimes it will be intentional. This should not be allowed to continue. If you've gotten this far into this video, it probably either is or will be your job to fix that. And that requires writing test code. Now, I already made a video on software testing, and I'll link it here, but there's a problem. My video on software testing is the least watched video on this channel at the time that I'm recording this. There's a vicious cycle here. Most programmers don't want to deal with or think about or learn about error handling, which means most discussions of testing and error handling don't get watched, don't get read, and they don't sell well. Which means authors and content creators tend to skimp on those topics or skip them altogether, which reinforces the programmer's desire to believe that error handling isn't worth the time to learn. As for me, I'm stubborn and I detest bugs. So I'm going to keep making content like this, even if far fewer people watch it than a lot of my more popular videos. I think we need to spend more time worrying about bugs and corner cases and unusual situations. We need to talk about topics that are unpopular and impolite, like calling out companies by name when they publish buggy and secure code or lie about what their code can do or how reliable or secure it is. And we need to talk about things that are popular in this industry, but that are horrible, like leak code interviewing and Agile and Scrum, and caring more about stupid acronyms like SOLID and whether or not a method is too long instead of caring about errors being handled correctly. Coming back to this video's topic, the contents of the book Philosophy of Software Design by John Ousterhout, the contents of this book are fine. They're much better than clean code. But if you think that software design books, no matter how good, or architecture techniques and design patterns, no matter how smart they make you sound or feel, will help you write code that's good enough, you're just wrong. Because as the single most important sentence in this book says, 90% of the catastrophic software failures are caused by bad error handling, and this book does not deal with error handling. So during all the time you spend reading and discussing books like Clean Code or this one, you're ignoring 90% of the catastrophic failures in software. And during all the time you spend on leak code, or whether a particular algorithm is order in or order log of in, you're ignoring 90% of the catastrophic software failures. During all the time you spend on design patterns or Liskov substitution principle or open for extension but closed for modification, you're ignoring 90% of the catastrophic software failures. All the time you're in stand-up meetings or sprint retrospectives, and any time that you or your teammates think or horror of horrors say out loud that a bug isn't worth fixing or that writing test code is someone else's responsibility, you are enabling 90% of the catastrophic software failures. So if you want to read this book, be my guest. But if you don't want to be a contributor to the Internet of Bugs, then your time is almost certainly better spent working on error handling and learning how to write better automated tests. And anyone who tells you that acronyms like SOLID or topics like design patterns are more worthy of your time than error handling is probably trying to sell you something, and they're probably part of the problem. I urge you to use your time wisely. Let's be careful out there.